Alright, so here I am inside of the mannequin-based animation blueprint, the same one as the previous video, and again, you can get to it by pressing Control, the spacebar, opening up the content drawer, and navigating through contents, characters, heroes, mannequin, and animations. It's this animation blueprint right here. So I'll start us off by reading through this animation blueprint tour comments right here, and excuse the scrolling in or zooming in on my screen. My mouse wheel is a little bit broken and I'm still waiting on a new one to arrive. So this Anim Graph does not reference any animations directly. It instead provides entry points for montages and linked animation layers to play poses at certain points in the graph. The graph's main purpose is to blend those entry points together. Example, blending upper and lower body poses together. This approach allows us to only load animations when they're needed. For example, a weapon will hold references to the required montages and linked animation layers, so that data will only be loaded when the weapon is loaded. An example is the weapon instance shotgun holds references to montages and linked animation layers. That data will only be loaded when the weapon instance shotgun is loaded. The weapon instance base is responsible for linking animation layers for weapons. So let's go over the overall flow of this main animation graph before we jump into any of the state machines. So we have our Locomotion state machine, and all that we need to know right now is that it outputs a Locomotion pose that can be modified by everything else in this graph before the output pose node is reached. So this is your walking, your running, you're moving around, essentially. You're jumping, and now the first linked anim layer is a left-hand pose override state. We'll come back to this. And then we have this Locomotion save cached pose. We take this cached pose, and we're applying, it's funny that I say we. I'm really used to creating tutorials where you guys are meant to follow along with what I'm doing, so I will talk in terms of we'll do this next, we'll do that next, and that seems to be carrying over into my explanation of how Lyra's animation graph works. I'll try to not do that, but I can't make any promises. It's become quite a habit. So now we are applying an additive pose using this additive identity pose node here. The alpha of which is a float titled upper body dynamic additive. We then take our cached Locomotion pose, take it through this slot upper body so that upper body montages can be played, and then we blend these together with a layered blend per bone. And then we have to go through another slot, which is titled full body additive pre-aim. And these slots are montage slots. So if you have an animation montage, you can assign it a slot, and when you have that slot in an anim graph, this is the point at which that montage will play. It's especially important if it's an additive montage, such as this slot here or this slot here. And this additive identity pose is being plugged into this slot here, which means that this is a completely additive thing, not dependent on there my mouse wheel goes again, the cached pose here. We're just blending this, we're applying this additive onto the cached pose. Unfortunately, I'm not sure exactly what this additive identity pose is or what it does. However, the thing you need to know here is that we have different groups here, that different montages are being played in, and then we are blending these together to create an output upper body, lower body split pose. We're then using that pose, and we're taking it through an anim layer with 3 inputs, a pre-aim pose, an aim yaw, and an aim pitch. And this layer is taking the character and making them aim based on your camera direction, your camera rotation. And then it goes through a slot which is an additive hit react, so any additive montage for hit reactions plays in this slot at this point in the graph. And then we have a linked anim layer, which is titled Full Body Additives, and we are applying those additives with an alpha of 0.65 before finally getting to the full body montage slot, which would be a montage that overrides everything, all the animation, the whole pose of the character. We're taking that through to inertialization, which is a node that facilitates a blending mode between states called inertialization, or in some cases there's some nodes that you can call inside of bound to animation node functions to swap out animations with inertial blending. And it's just a nice way of blending that takes into account the velocity, acceleration, the inertia of bones in the previous pose in the previous animation compared to what you're trying to blend to. And finally, we are rotating the root bone, which is done for turn in place. With the kind of setup Lyra has, wherever you look, the capsule and the entire character turn to face that direction, which is fine when you're moving around, and it's needed when you're moving around because much of the time you're aiming. When you're standing still, instead of toggling that off inside the character, we're just counter-rotating the root bone, so that when you turn your camera, the root bone turns in the opposite direction to keep the mesh inside the capsule facing the direction that they were facing when you stopped. Next we have some procedural fix-up using this full body skeletal controls linked animation layer and a control rig. And finally, we have our output pose. Now that we're done with our overview, I'll want to go into these layers down here eventually, but I do not think I'll have time for that today. Instead, what I want to really focus on here is this Locomotion state machine. So, we have this state machine here, and I think the biggest, most noticeable thing here is that it looks like there are two state machines in this state machine. And that's because there's a new node type, a new state machine graph thingy type thing, whatever you want to call that, called a state alias. And Epic explains it quite well right here with this example, if my mouse will let me scroll in. This is an example of a state alias. State aliases help to reduce the amount of transition lines required. This allows multiple states to transition to jump with the same condition, without having to have explicit transition lines from each source state. So here we have jump sources, which is saying that we can transition from any of these states to jump to this jump selector and into these jump states if this transition here is true. And that seems to be an automatic transition there, which is interesting. This transition seems to always be true. Meaning that it's going to go straight into the jump selector, and it will go through and into any of these states if and only if one of these conditions is met. And again, the previous video we went over the event graph where most of these variables are set, and so this is jumping boolean and this is falling boolean is an example of two variables that we briefly touched on in that video, which will be linked in the description below. And chances are you probably might even be watching this video in a playlist with that video in it as well. So the state machine starts at this entry node here, and we go straight into idle. And this brings us to one concept that's not new to Unreal Engine 5, but is very much improved over Unreal Engine 4, and another concept that might be new to you. So we're using a linked anim layer for idling, but if we open up the anim layer inside of this blueprint, there's nothing there. And the reason for this is because, again, it has to do with loading in different animations and not needing to keep all the animation sets loaded. So the layers themselves are stored in other animation blueprints, and there's an animation blueprint for each, essentially, item that can be held. So you have an animation blueprint with the layers filled in, with all of these layer graphs filled in for being unarmed, for the pistol, for the rifle, for the shotgun, etc. And the layers of that animation blueprint class are used to override the layers of this animation blueprint class with a specific node. And I will show you guys one example of that node briefly here. If you go over into your content browser, go into the plugins folder, into shooter core content. I believe it's in, not blueprints, let's see here. Game. We have this hero shooter mannequin blueprint. I will go ahead and open it up. And now there are, let's see, there is a function here. Nope, it's not a function, my bad. I believe it is in the construction script. Is that open here? Nope. Yep, it is. Here we go. Here's the node. It's the node called link anim class layers. It takes a mesh as an input, and then you just assign an animation blueprints class to the node, and it will link the layers of that class to the layers of the animation blueprints that the mesh is using. And I've talked a lot about linked layers, but I haven't covered exactly how we get these linked layers to begin with. And we can do that by going to the class settings for an animation blueprint. Under interfaces, we can add an animation layer interface. In this case, item anim layers has been added, and to link the layers of one class to another, we have to add that same interface to the other animation blueprint. And that interface can be found if we go back into content, characters, heroes, mannequin, animations, linked layers. It's titled ALI_item anim layers. And here we can see that a number of layers were created with different names, and this one, for example, has some inputs. It's the full body aiming one we've already briefly looked at in the main animation graph. And then we have this other one, full body skeletal controls, which also has an in pose input. So now that we understand the interface, I'm going to go ahead and open up this item anim layers base, because this is the animation blueprint that the unarmed animation blueprint inherits from, that the weapon animation blueprints inherit from. This is the blueprint that all of them inherit from. Now I'm going to close out of all of this and start fresh. I'll open up the event graph, but again, it uses property access inside of different functions to do the things that would usually be done in an event graph. It uses that same blueprint thread safe update animation function. Now, this whole animation blueprint is pretty complex, and I do not have the time to cover it in this video, but I will be covering it in a future video. The thing I want to show you guys is that if I go to animation layers here, open this up, I can find, let's try to find idle. Here we go, we have the full body idle state, and this is the layer that would be, well, a child class of this animation blueprint. Its idle state machine, its layer here, would override the layer here in the base animation blueprint. So this is where you'd find the missing anim node stuff if you've been looking for it at all. And so this idle state machine has turn in place states, an idle state, an idle break state for playing different animations that could break up an idle, so you're not just standing there in the same pose constantly forever. But again, I'm not going to cover this whole graph in detail in this video. I think that will be the next video. Instead, I want to come back over into this main animation graph and continue to go through it, because I just exited the idle state for no reason, so I'm going back into it, and we have this output animation pose here. And one thing to note is that there's a function bound to it called update idle state. And to bind a function to a node like this, you just click where it says none, and you'd create a binding. And that will create a function with some inputs that are automatically being given the data needed for the function. And that function will be called, if you've bound it to an update, whenever this node is updated. You can also bind it to the initial update of the node, and also to whenever that node becomes relevant. So I am going to go ahead and search up this update idle state function. Here it is. And so now we can see how Lyra assigns different bits of logic to run at different times depending on the active nodes in a graph, which is a much more efficient approach than what was done usually inside of Unreal Engine 4, where we didn't have this extended capability with these bound nodes, and we just end up doing a whole lot of this stuff in the event graph. So this is definitely a workflow you'd want to adopt for your own systems and projects, even if they are not as complex as Lyra. But that's just my opinion. So it's my understanding that this node output is the node that you've bound the function to. But because it creates the same node input for every function you bind to every type of node, it does not know what kind of node you've bound the function to. You can bind it to any node. So you could bind the same function to a player that you could bind to an evaluator or an animation state output, such as this one. So the function inputs cannot be node type dependent, so that whenever you want to call a function that is dependent on a node, what kind of node the function is assigned to, you have to take this node value and convert it to the type of function, the type of node that you've assigned the function to. So my mouse just died on me, and I had to replace the battery, and I've cut the video. I'll try to start off where I left off. So we have this convert to animation state, which is the type of node that this function is being assigned to, is being bound to. And we're doing that, and Lyra is doing that so that it can call this isStateBlendingOut function. And it also takes this update context. Now, I'm not exactly sure what this context means or does, but look at enough of this stuff and you'll get a pretty good idea of the functions you can use and what it's used for. You can also, if you just want to play around, you can drag out from it and look through all the things you could do with the context inside of these functions. And so if we're blending out, it sets the turn yaw curve value to 0 and a root yaw offset, and it sets a root yaw offset mode to accumulate. And again, root yaw offset mode, the root yaw offset mode stuff is something we briefly touched on in the previous video. And next, it's calling a function called process turn yaw curve. And so this is processing root yaw stuff for turn in place. Again, to keep this video down to a certain time threshold, I'm not going to cover every aspect of this animation graph in detail in this video. This is much more of just an overview here. So that's the update idle state, and I will be doing a much more in-depth look at these individual states and their layers in that other item anim layers based blueprint in the future. my current plan is to do a video on the idle state, a video on the start state, a video on the cycle state, so on and so forth, to explain all the concepts and things used in each of these states. So now there's a transition from idle to start, and we'll transition to start if we have acceleration, or if the gameplay tag is melee and we have velocity. And start is using the full body start state layer, and it is also applying an additive to that output pose. And this additive is a blend space titled Rifle Jog Leans, using an additive lean angle float. Now, we're seeing a lot of floats now, a lot of variables that aren't just floats, I think we'll be seeing, that aren't set in the event graph. And if they're not set in the event graph, they're going to be set in one of these functions somewhere that is bound to a node. And if you're looking ahead of these videos, trying to figure things out, and you're trying to figure out where a variable is set, you can just go to this find button here, type the name of the variable. We can type additive lean angle in here, and we can find where it is set. And it is set in an update rotation data function. So looks like I didn't remember, but we would have looked over this in the previous video, but there have been and will be other variables that are set inside of these functions, and if you're ever looking for where one is set and you can't find it, just use find results or search through the functions either way. So we are applying this blend space, which is a leaning additive for when you're running forward and when you're jogging forward and turning. Now, it's showing the hands going back and forth here, but I believe that this would also be able to be used on an idle state. I think this is just an effect of the base pose that this additive is being applied on top of. This is probably only, let's see if I can find it here. Or let's just look at the actual sample. Leans left. Yes, this additive is being applied onto this base pose by default, but it can be applied to any of the poses, and it's just going to lean the character to the left, and the other one would lean the character to the right. So now we have two functions bound to this state. We have a setup start state and an update start state, and this is a pattern you will see everywhere in Lyra. A setup state, an update state on the states, and if it's being called on a player or evaluator inside of the other animation graph, it'll be a function called setup blank anim and update blank anim. And that blank you'd fill in with the name of the state or whatever sort of animation, like the idle animation or the start animations. So let's go ahead and find these functions. We can just search set up start state, and this one is just taking the local velocity direction and setting a start direction. And I opened the incorrect setup state function there. I need to type update. Now we have our update start state, which is testing whether or not the state is blending out, and if it is not blending out, it is updating the root yaw offset mode. So start will transition to cycle if the animation is finished playing, which is done by checking this automatic rule based on sequence player in state. It will also transition to start if the start direction is not equal to the local velocity direction, or if there's been a change in the crouch state, whether you've started to crouch or you've stopped crouching while starting, if your aim down sight state has changed, and also if the current state time is greater than 0.15 and the displacement speed is less than 10. It will also change to cycle if the linked layer has changed, so if you've swapped weapons. And it will change if the root. So here, I'll read this comment in this one. Transition to cycle early if the offset is too large. Example, if the camera is on the right side of the character and the user presses forward, we don't want to strafe left for a long period of time, we want to jog forward. This transition uses sync group name to require valid markers rule setting to ensure we wait until there are valid sync markers so that we smoothly enter cycle. Which is actually new, I haven't encountered that before. Here it is, sync group name to require valid markers rule. And so that's a useful thing that I just learned about while recording this video. So if one of these is true, it will transition from start to cycle, and the priority order can be set for each of these transitions right here. And the priority order of the will essentially, well, I'll just read this. If multiple transitions out of a state go true at the same time, the one with the smallest priority order will take precedent. So that's what priority order means. Next, we go into the cycle state. We have the cycle state layer, the same leans and additives applied, and this time there's no setup or update state function bound to it. Now from cycle, we can go into stop, and we're going to stop if we do not have if we do not have acceleration, or if we do not have the melee gameplay tag and have velocity. And the stop state uses the full body stop state from the linked anim layer, which we'll look at in a future video, and this update stop state function. So let's look at update stop state. And these have been pretty simple functions so far. The ones in the base layer, the base item anim layer blueprint, get much more complex. So we're, again, determining whether or not we're blending out, and if that is false, we are setting the root yaw offset mode. Stop can transition into start if we have acceleration. Start can transition into stop, with the same transition as cycle going into stop. Stop can go into idle if the animation is done, if the crouch state has changed, or the aim down sight state has changed, or if the linked layer has changed. Then we have our state alias here for pivot sources. And the transition here is checking if the dot product of local velocity and local acceleration is less than 0. If that is true, and if is running into wall is not true, any of these states checked in here will transition into the pivot state, which again is using a anim layer that is linked, and we have a setup pivot state and an update pivot state function. So let's take a look at those. It's setting a pivot initial direction. And this one, it's taking a last pivot time variable, checking if it's greater than 0, and if that is true, it is taking the last pivot time, subtracting the delta time, and setting the last pivot time again. Now this last pivot time is actually being set in the other item anim layer's base blueprint to point to at the start of the pivot state layer. Whenever that starts on when it becomes relevant, this last pivot time gets set to 0.2. We de-increment it, we subtract from it every tick inside of this animation graph, and we read from it in the other graph to determine when and as long as this is greater than 0, that graph will, in that graph you can change from one pivot, you can blend from one pivot animation to another while you are pivoting. This stuff will become much more clear and easy to see when I go into each of these linked anim layer states in depth. I might combine some of them into multiple videos. I might dedicate a single video to one of them if it's particularly complicated. We'll see how it goes in the future. So now we can transition from pivot to cycle if the animation is done playing. If the, let's see here, let's open this up. So if the crouch state has changed, or if the aim down sight state has changed, or if we're moving perpendicular to the initial pivot and our last pivot time is less than or equal to 0. And this is moving perpendicular to initial pivot is a function that just uses the pivot initial direction variable that was set in the setup pivot states function, and it is comparing that to the local velocity direction. Let's just go through an example here. So we have our pivot initial direction. Let's say we're starting and we're going forward. And let's say we're still going forward. So it equals forward because, so it equals forward. So this OR becomes true. And the first point, this first spot in the AND becomes true. Local velocity direction is also forward. So this is true. The not converts it to not being true. And so this AND is not true because this not has made this right here false. So this is now, this top input for OR is false. Now our pivot initial direction was neither of these. Our local velocity direction is neither of these. So this is going to be false, and this is going to be, whoops, I added a pin there, and this is going to be false. This is going to be swapped around to a true because of the not node, but because this is false, this output is false, so that both inputs into the OR are false, and the return value is false. We are not moving perpendicular to the initial pivot. Let's say we've started going left, and now we're going forward. Well, these are both false, so that's false here. But forward here is now true, but that gets converted to a false, and that input is also false, so the top input into this is false. Now our pivot initial direction was left or right, I don't remember, but it doesn't matter in this example. So this is true. Our local velocity direction is neither of these, so this is false. It gets converted to a true. And now both of these inputs are true, which means this bottom input is true, which means we are moving perpendicular to the initial pivot, which means that if the rest of these, if this condition is met here, we can transition from a pivot to a cycle. And now we can transition from a pivot to a stop if we do not have acceleration. That's it for this side of the animation graph, or the state machine. So now we have the jump selector. If we're jumping, we do this jump start. If we are falling, we do the jump apex. Jump start can will transition into jump start loop when the jump start animation is done. No bound functions here, just a layer. Jump start loop will go into jump apex when time to jump apex is less than 0.4. So let's see if we can't find where that is being set. So let's search up time to jump apex. Hit enter, and here we go. It is being set in update jump fall data. So we can search update jump fall data. And I was leaning down and over to see around my microphone there. And it is being called an update in Blueprint thread safe update animation. Now once we are in the jump apex, once this transition becomes true, and it does when the jump apex animation is done playing, we'll play the fall loop animation. And this is checking whether if the distance to the ground is less than 200, then we play a fall land animation. And the fall land animation inside of this layer is being distance matched based on the distance to the ground variable that we can see right there, the ground distance variable. And again, I believe that might be set in this update jump fall data. No, so let's search that up. Update ground distance. There's a typo. Or not. That's why. It should just be ground distance. It's not, the variable itself is not called ground distance. So it looks like this variable is not being set in this blueprint, which means it would be being set in the other blueprint, the item anim layers base blueprint. So we'll find that when we cover jumping in a video on jumping, where we can go over this, where we'll go over the different anim layer states and functions bound to them and the item anim layers base blueprint. So once we're done distance matching that land and we are on the ground, we go through a conduit here, and if we have acceleration, we go into cycle. So we're using aliases. And if we, so it seems like if we don't have acceleration, to pay attention to the priority order here. So if we don't have acceleration, then we'll default into the idle state through the idle alias. And here we have jump fall interrupt sources, which is jump start, jump apex, fall land, jump start loop, and fall loop. So if any of those states somehow we are in them and we are on the ground, we go into this sort of selector, this conduit. Is it called a conduit? Yes, this conduit. And we either go into the cycle or into the idle. And that is the main state machine for the main locomotion state machine for the animation graph. Now, I'm going to end the video here. I've been recording for 44 minutes now. I'll probably cut some of this stuff out of the video. A couple of mistakes I made during recording when I got up to take the battery out of my mouse and replace it with a new one. And in the next video, I'll begin to go through parts of the item anim layers base animation blueprint so that we can see how these two things relate together. It's hard to understand everything that's happening here until we can understand both of these animation graphs. And that I'll probably split up into multiple videos, and then eventually we'll get around to covering this section in more detail, and then this section in more detail after that. And at that point, I think the series will be over. So thanks for watching, everyone. I hope you found the video helpful. If you did, be sure to leave a like and subscribe to the channel. It really helps the channel out much more than you realize, much more than, I would have thought to realize before I started a YouTube channel. And there's also a link to the Outcast Dev School Discord down in the description below, so if you want to, come join us there. And I will see you in the next video.